Okay, so hello, my name is Ben Taylor. I've been the service manager of NIADAS, among other roles, for the last few years here at Plymouth Marine Laboratory. My background is in computing and then in oceanography. I apologize for talking to you sitting down. I don't normally do that. I hope I'm not too boring. I realize it's the end of the day and it's warm in here, but I hope you can all stay awake for a few minutes longer anyway. So NIADAS is the NERC Earth Observation Data Acquisition and Analysis Service. You will, of course, all be tested on that acronym at the end. It was formed in 2006 from the merger of two existing facilities. One was the Dundee Satellite Receiving Station, based at Dundee, as you might imagine. And the other was the Remote Sensing Data Analysis Service, based here at PML. And it was converted into what's called a dual node facility of NERC, and that's how it exists to this day. And it exists to provide a central access point for Earth observation data and expertise to researchers around the UK. So why does it exist? It's slightly the wrong question. The question is not why does NIADAS exist. The question is why does NERC fund services and facilities in the first place? And the answer is that there are capabilities that if you left them up to individual universities, most of them wouldn't do it, and the ones that did do it would do it twice a year and would do it badly as a result. So it makes a lot more sense to take something like, for example, a research aircraft, fund it centrally, make it available to people around the UK, and have a core team that's what they do, and they develop the procedures, and basically everybody wins as a result. In the case of NIADAS, this is not a research aircraft. It's provision of satellite Earth observation data to UK-based researchers, also data reception, expertise, processing. So start with Dundee. Dundee Satellite Receiving Station, now NIADAS Dundee. It's been around since 1975. First dish had its 40th birthday a couple of years ago and is still going strong. It either receives or has received from 21 polar orbiting satellites, various flavors, and also 8 geostationary satellites. The polar orbiting satellites it receives in line of sight, so that's the footprint that you can see up in the top corner there. The geostationary ones, the data are available worldwide, and they're available every 3 hours, and you can go on their website and they'll just appear. So examples of these, the AVHR image. AVHR is a polar orbiting satellite, and you get something like the image on the left here. And the one on the right is the geostationary Severi, which sits over the equator and over 0 degrees longitude, and you get a full disk image like that. And it's used for a variety of things. Dundee has a large number of users, most of whom are interested in the weather. And you also get the odd sort of slightly unusual application, like this is the eclipse in 2015. And you can see the line of the eclipse advancing out of the terminator up in the top there. 2015, because that was towards the UK rather than the recent one that made all the fuss in North America. Unsurprisingly, for Satellite Receiving Station, they've got some pretty big and obvious hardware. They've got 8 antennae, 5 tracking and 3 fixed. I'm sorry I haven't got this animated because actually they're quite interesting to watch, especially sped up, sort of flicking around. They've got dishes of various diameter up to just shy of 4 meters, various band reception, computing facilities to support that, and a fast internet connection to ensure that they can disseminate the data worldwide. And they have in the past downloaded unique data. So there was an archive of CWIFs which was the NASA satellite that NASA didn't have for a long time, and they only recently negotiated access to Dundee's archive to include that in the main NASA archive. Plymouth Node, as I say, started life as the Remote Sensing Data Analysis Service in 1995. We download data from Dundee, also from other data providers, NASA, NOAA, European Space Agency, sometimes others. And we generate mapped geophysical products. So where Dundee focuses on direct reception of satellite data and provision of the sort of lowest level of the data, the Plymouth node, us, we take that and we provide maps of things like chlorophyll, sea surface temperature, whatever it happens to be, and we provide that to UK researchers. We're a marine lab. We do have a bias towards marine products, but we are keen to expand into other areas if you've got something you're particularly interested in. The workflow is completely automated, so we want to go from the satellite reception over the far side to the users over this side. And in between, we have automated systems that go and watch the servers and the data providers for every 5 minutes. And if they see a new file, they download it. It gets run through our systems here completely automatically. We produce the higher level products. Those appear on our website completely automatically. They're also provided to researchers at sea in near real time or other field campaigns. And they're also provided where people are interested in historical data. So people can come to us and say, can I have a map of sea surface temperature of Wales for the last 5 years or something like that? And we have that archive and we can provide it to you. So we have what you might call standard products that you can get from us. You can also get from other data providers like NASA or Copernicus, for example. You might not be able to get it quite so conveniently from them. So, for example, if you want chlorophyll A, yep, you can go to NASA and they'll have it in 4-kilometer resolution. If you want the 1-kilometer resolution, then you can either process it yourself, which will be a complete pain in the backside if you're not used to what you're doing, or you can come to us and we can give it to you. And we've got a number of satellites that we use at the moment. So the main ones at the moment are ALCHI, which I'm sure you've probably heard a fair bit of these this week. ALCHI, which is a new one, 300-meter resolution. VIIRS and MODIS are both American satellites. MODIS is the calibration starting to go off a bit, so it's not used quite so much as it used to be anymore. We have in the past also used other satellites as standard, so the older CWIFs and MERIS satellites, for example, with sensors, I should say. On sea surface temperature, we primarily provide data from AVHRR. We do also provide microwave sea surface temperature, which is coarser resolution, but has the advantage that it can see through clouds. And in the not too distant future, we're expecting to provide data from SLSTR, which is the new one on board Sentinel-3. So those are the standard products, if you like. We've also got products which were developed here in-house at PML and that you can't get anywhere else. So those include things like maps of thermal fronts and maps of phytoplankton size classes. Both of those algorithms were developed here and are not available from other data sources, unless, again, you want to go all the way back to the primary literature and implement the thing yourself, which you don't. And then we've got things that are a bit less in our usual line, but are still available. So, for example, we can provide synthetic aperture radar products from Sentinel-1. And the image on the left here is an oil slick off Malaysia, or between Malaysia and Singapore recently, which has had automatic oil slick detection run on it. And on the right, we have Sentinel-2, which is not optimized for marine applications, so in some ways it's less useful for the kinds of things that we tend to do, but it is much higher resolution. So where I say ALCHI is 300-meter resolution, and that's quite a new one, Sentinel-2 is 10-meter resolution. So you can see there's a massive difference there, and where there are useful algorithms there, for example, there's quite a good suspended particulate matter algorithm. You can get some really good information from that. And the product list here is the list of the standard, if you like, products that we have available, though if you want something that's not on the list, we'll do our best to provide it. Hardware, we do an awful lot of computing. We outgrew our old server room a few years ago, and a new one was put in. We got about 2.5 petabytes of storage, and we're always short. We always want more. We have about 150 computers in our processing grid they automatically receive jobs that are, as I say, downloaded from whatever the data provider is and farmed out to these computers in the processing grid to run automatically. And we run through about 10,000 processing jobs a day, that kind of order. And we also have a fast internet link through Janet. But enough about that. You don't actually care what our computing facilities are. What you want to know is what we can do for you. And the answer is we have an awful lot of data. We have it. You want it. We want you to use it. We want you to do good science with it. Please come and use it. We also provide an extra layer of customer service over and above what another data provider like NASA or ESA might provide. So if you go to the websites of those data providers, they will have the data they provide, and that's what's available. And if you want something else, so for example, you want higher resolution data, 1 kilometer versus 4 kilometer, or you want a different processing area, or you want a different file format, or you just don't know how to use the file format they're providing, you're kind of on your own. Whereas we will do our best to provide what you're able to use, or to help with how you use it, help to tell you how best to make use of it. Or also, you can also just come to us and say, look, this is what I'm trying to do. I think there should be some satellite data that should be useful, but I'm not sure what. Can you help me? And we'll do our best to provide something useful. The pretty picture here is a Sentinel-2 image of Rio just before the Olympics last year. I know it looks like it's horribly polluted, but it's not actually the case. It's just the difference in the water that's coming out of the lagoon. Another thing that we will tell you about when you come and get our data are the limitations on the data. So for example, sea surface temperature can have problems with misdetection of cloud, especially where it's a low-lying sea mist. Might not be too different in temperature to the water it's above. It's quite hard to detect. Or for example, chlorophyll algorithms often have problems with water that's very turbid. They tend to overestimate chlorophyll. The inset image here with all the red is nominally a chlorophyll image, and you would look at that and think there's a massive chlorophyll bloom in the Irish Sea. Well, there isn't. That's the middle of winter. That is largely suspended sediment in the water that has fooled the chlorophyll algorithm into thinking that there's a lot of chlorophyll there. So again, there's this kind of thing that you need to know about in order to make best use of the data. We can provide help reading the data. We make extensive use of Python. It's easy to extend, it's easy to use, it's hard to break. It's got good libraries for use of numerical data and plotting of the same data. We do also have experience with a variety of other languages and things like GIS packages to some extent, and we'll do our best to help you with those. We're not a customer support service for something like ArcGIS, but we will do what we can. Something I mentioned earlier that is a major part of what we do near real-time support for field campaigns, typically research cruises, but also airborne or atmospheric projects. And basically what we'll do is you come to us before the cruise and say, this is where we're going, these are the products we're interested in, and we will provide a daily email bulletin of satellite images of your area, your products. And we'll have looked at it, we'll focus in on the area around where you are, as long as we know where you are, as long as you're on a ship that we can find. And we'll also provide a little bit of interpretation. We'll say, well, you know, there's this over here, or you know, this is over here, but actually we don't think that's genuine, or there's an eddy up here, or whatever it happens to be that we think you'd be interested in. And this is useful for both for providing a synoptic overview of your experiments. So if you've got, yesterday I measured the temperature is 10 degrees and today it's 12 degrees, you know, have I crossed a front? Have I gone into an eddy? Has my temperature probe broken? What's happened? So you can get an idea of the wider area around you. But it's also useful for planning your sampling strategy for research campaigns. So if you're interested, if you're out on a cruise and you want to find a plankton bloom to sample, you could go to somewhere where you think they're common and steam up and down for 3 weeks and hope you run into one. Or you could just go there. You could take a satellite image and go there. There's one, go there, and then spend your time doing research instead of steaming up and down hoping to find something useful. And the images here are a couple of examples of this. The bottom corner one there, smaller one, is from a cruise campaign called Eurobasin, which did exactly this. They used our satellite data to decide where they were going to go and sample. The other image is, you may remember a few years ago when the Eyjafjallajökull volcano blew up in Iceland and grounded all the planes for weeks, months, however long it was. It just so happened there was a research cruise out in the area that was being supported by us and found themselves under this plume and managed to get some very good and interesting measurements and got some interesting papers out of that. I'm not actually claiming that was anything to do with us. They happened to be under the plume, but we were supporting them and we were able to say, look, there's the plume. This is what's on top of you. So how do you get the data? Well, first and easiest way is you go to our website, and you will find our multi-view browser, which will let you view images day by day of the particular regions that we're processing, and that's quite good, particularly for looking at single images. It's less good for looking at a time series, but for single images, it's not too bad. For a time series, you want something more like our fairly new bulk download interface. Which will allow you to go and say, right, these are the areas that we've got processed. I want this area. I want it for this date, for this satellite. And it will allow you to download our entire archive. Except it won't. What it'll actually allow you to do is to download 2 weeks' worth of data. And if you want more than that, then you need to get in touch with us and tell us what you're doing. And we will then extend your quota to allow you to access more data. Dundee has a similar sort of web interface. You can go to their website and find the imagery that they've received. It appears very quickly after acquisition, a matter of a few minutes, and you'll be able to see what's there, the cloud patterns. You can see things like dust coming off the Sahara, all that kind of thing. And they have an image gallery of different phenomena that have been seen in their imagery going back over the years. And then if you want something a bit sort of larger, you want us to do something specific for you, then you need to go to our online application form, fill that out. If you have a NERC grant, then we'll just be able to support you. If you don't have a NERC grant, then it'll need to go for peer review by our steering committee. And assuming that they say your science is good enough, then we will provide your data and we'll be able to provide you with the support that you're interested in. There are some rules around this. If you're applying for a NERC grant and you think you might want to use our data, you need to put on the grant form that you want to use NIADAS and how much it'll cost. That involves getting in touch with us and saying, this is what I want, and I'll write back and say, right, that's fine, this is what it'll cost. You include that on your grant form. You will not see that money. We will not see that money. NERC will move it from one pot into another one, and everybody's happy. If you don't have a NERC grant, then you can just apply directly for access to the facility, but then, as I say, in that case, it needs to go for peer review by the steering committee. Either way, you do need to be eligible for NERC support, which basically means you need to have a full-time post at a UK higher education institution or an eligible independent research organization. There's a list of these on the Research Council UK website. If you're not eligible, for example, PhD students are not eligible, then you need to find someone who can be the PI. In the case of PhD students, that's your supervisor. If you're, for example, not UK-based, then you could find a UK collaborator who can act as the PI, and we can provide data that way. Or you can talk to us directly, and we can see if we can collaborate with you ourselves. Supporting science is the reason we exist. As I mentioned, we've got a bias towards, in Plymouth, we've got a bias towards marine data, science, sorry. In Dundee, there's a bias towards atmospheric data, but there are examples of use across all of NERC science themes. Since 2006, we've supported over 630 peer-reviewed papers. And we're getting on for 3,000 citations of those to the end of 2016. And we're, as I mentioned, we're also interested in collaborating. If you're doing something interesting that needs a bit of development, we might well be interested in helping you out. Please talk to us. And I've got some examples of the kinds of things that NIRAS data have been used for. So an example to start with, phenology. This is something that was done by Marie Fanny. And she looked at the effect of El Nino on the timing of the phenology of ocean events. And she found that an El Nino year globally affects the growing period by plus or minus a month in length, chlorophyll concentration by plus or minus a fifth, and primary production by plus or minus a tenth. And those are enormous effects. They're really big, which is why El Nino is such a big deal. But they're also quite localized and vary quite substantially from one point to another, and sometimes those points can be quite close together, as illustrated by the red-blue map in the corner here. So this is one kind of thing that's been done with our data, and she used NIRAS data for that. We have ecosystem applications, so we get quite a lot of applications where people have got observation data for, I don't know, seals, basking sharks, seabirds, whatever it happens to be. And they want to use satellite data to compare where the seabirds have been to what the environment was like to see what was there. So for example, it's very often compared to thermal front data. This particular study looked at gannet diving behavior compared to thermal fronts. So gannets do two types of dive. They do what's called a V-shaped dive, which means they dive, they grab something to eat, and they come straight back up, easy. Or they do a U-shaped dive, which is they dive, they miss whatever they dived at, they swim around for a little bit hoping to get lucky, and then they come back up, whether they did or not. Obviously, if you're a gannet, you want to do a V-shaped dive. It saves you a lot of energy, and then you get a meal. So what was found in this paper is that at front locations, there is a greater proportion of V-shaped dives, which basically means that at fronts, the gannets are hunting more effectively, more efficiently, and they're feeding better. And this is a pattern that we see repeated, where different animals that have been tracked feed better, feed more efficiently, feed more often at thermal fronts, or places where there is a greater density, a greater occurrence, greater frequency of thermal fronts. So this is useful, for example, for informing conservation efforts. If you want to define a marine protected area, you probably want to protect an area where there are a lot of fronts, because you know you will be protecting the food source of a lot of different animals by doing that. Something that was looking at interaction between atmosphere and ocean. This was the Acacia project from a few years ago. And this was looking at models, cloud models in particular, of the Arctic. And the problem they were looking at is that cloud models in the Arctic have a lot of uncertainties in how they behave. And that's a bit of a problem for climate models, because the Arctic is warming faster than pretty much anywhere else. And clouds have a big effect on that because of albedo, among other things. So if you're not modeling the clouds correctly, you're probably not modeling the climate change correctly. So this project was looking to reduce those uncertainties. And they had 2 research cruises in 2013. They had some research flights, and we provided support for all of those. And that's resulted in, for example, a special issue of Atmospheric Chemistry and Physics, other papers. Another example of ocean-atmosphere interaction. This one's going back a while now. This was Solis Icon from 2009. But the reason I've still got this in is it's quite a good example of use of our data, in that they were looking at the Mauritanian upwelling off West Africa, and they were wanting to follow a parcel of upwelled water to see how it developed over time. And if they just sent the ship out there, you couldn't do that, because you'd wake up the next morning, you wouldn't know where the water had gone. So they needed the satellite data to show where the filament was going as it moved offshore, and to be able to follow it. And they got a variety of papers from doing this, and they actually followed 2 filaments while they were out there. Another application, citizen science. So this is a paper that's been looking at using, shall we say, platforms of opportunity, surfers. And so the problem is here that if your satellite data close to the coast is always problematic for a variety of reasons. And one of those reasons is that the amount of in situ data that's available to check that your satellite is correct is not very large because the ships tend not to come that close to the coast. Surfers, on the other hand, are right off the coast. So if you take a low-cost temperature sensor and you attach it to a surfer, and then he goes out 50 times in the year and measures temperature while he's having a good time, you get some good data to do validation on your satellite data set. So that's what this paper has been looking at. And then something completely different and non-marine, and not even necessarily what you'd expect from atmospheric satellite. This paper was looking at dust storms in Saudi Arabia, or one particular dust storm, and it found that the storm in question had been triggered and sustained by a cold front coincident with an intense upper level jet streak. I'm not an atmospheric scientist, that doesn't mean anything to me, but all the same, it's an example of the kind of variety of things that the data can be used for, and that was Dundee data. We've got a whole host of different examples. So there's Dundee data is used for a lot of different atmospheric and meteorological examples, like the top two, one of which is in Nature Communications, so that was quite high impact. We've got a comparison to remote sensing data collected from an aircraft over lakes, biogeochemical cycling, volcanoes, glaciers. I said earlier that we run the gamut of the NERC science areas, and we do. So whatever you're interested in, we can quite possibly find some data to help you. So, in conclusion, NIADAS is centrally funded to provide satellite data to UK researchers, though we are also interested in collaboration with overseas researchers. We can help with provision of satellite data and processing of satellite data that you might be interested in. We're also interested in new algorithms, if you happen to have any. And we have a very strong ability to provide tailored near real-time data that is what you want when you want it. And we provide data that has underpinned a lot of successful science, and we hope and expect to keep doing that, and hopefully some of your science. So that's all. Thank you very much. Any questions?